Hi, today I'd like to teach about logarithms. We will use logarithms to solve these kind of problems, where the variable that we're solving for is the exponent. You may be used to solving problems like x squared is equal to 16. This problem is pretty straightforward. Just take the square roots of both sides. So in this case, x is equal to plus or minus 4, is the square root of 6. But when x is in the exponent, you will need to use logarithm. So a logarithm will say, what power do you have to raise 4 to equal 1020? The notation is like this. Log base the number to raise this number to raise base to the exponent is 1. That is equal to the x is the x. So we'll apply this to logarithm. You have to use log base. In this case, the base is 4. Log base 4 of 1000 and now we can't, this one we can easily solve just by multiplying 4, and that gives us, 5 times, gives us, so when you have 4 to the power 5, that is equal to 1000. That's what our logarithm function. Now you might be asking, why do we need the logarithm? Just keep multiplying base. Well, it becomes more clear when you start solving more difficult. Now let's say you have something like this. You write it in. Let's say 5 to the power equal to 3,214. Some random. Now, obviously here, 3,214 is not a multiple of 5. 5 will never. So in this case, the exponent is actually a decimal. And the only way to get this decimal easily is to use a calculator and with the logarithm. So in the calculator, you have to enter log of 3,214 divided by log 5. Yeah, I don't think. So in this case, we don't have a base because you can't enter a base in the. So the base by default is 10. But when you divide this number by this number, this is. So you want to do log base 5, just put 5 in the denominator. I'm going to enter this into the calculator. So log 3,214 divided by log 5. This gives me, right there, 5.017. So we can cross-check this by entering in the calculator. 5 to the power 0, 1. And this gives 3,211.6. Now, of course, this is not the same as this, and that's because I did not enter I'll put the exact value here. But it gave a really close number. That's how you approximate the exponent using logarithm. Try some more. Here I will use a word problem. So let's say you have a bank account and some amount of money and has interest. So let's say you have $500, and then every year this $500 increases by 1% to 2%. So you have to raise this to the power of 1.02. This is our function. So now we're asked, how, okay, this is the real one. 500 times the interest rate, so 1.0 to the power of x. So this is the starting amount, this is the interest rate, and this is number of years that. So now let's say that we're asked, in how many years will the bank account reach $100,000? So in this case, the x is the number of years. We're trying to solve for x. So we have to use logarithm to set up our algebra equation. So 100 is equal to 500 times 1.02 to the power of x. And now we need to use our logarithm to find x, but first this needs to be isolated. So we have to divide 100,000 by 500. That is equal to 20. Okay. Now we need to use our logarithm. So log base 1.02 20 equal to x. Then again in the calculator, you have to put log 20 divided by log 1.02. That is equal to, x is equal to 100 and approximately equal to 151.2795. And this is the number of years that it takes for this bank account to reach 100. We can double check by doing 500 times 1.02 power of 100.79. And that does give me 1,000. So that's it for this tutorial. Hope you enjoyed, and I will continue making more math and